Welcome guys to this video. We want to solve another series of challenge which says 3 to the power of m minus 2 to the power of m is equals to 65. So you are looking for the value of m. So how can we solve for the value of m in this challenge? So if you are new here, please subscribe, and by the time you subscribe, turn on the notification button so that you get notified anytime I drop videos on mass. So let's see how we can solve this challenge. Looking at this challenge very well, we are having 3 to the power of m minus 2 to the power of m. And if you can see very well, we are having 3 as the base number at this side, and we're having 2 as the base number at this side. But the exponents are the same. How then can we look for m with this? If we want to apply it, we can't really apply a directric. We can't really apply a directric. Because if we say we should apply the directric, then we can say let us factor out something out, then apply the directric. But in this point, we can't factor anything out because we are having 3 here, we are having 2 here. We can't factor out 2, neither can we factor out 3. Other will say, okay, well, let's solve this by dividing both sides by 3 to the power of m. If you divide both sides by 3 to the power of m or 2 to the power of m, you are making this equation more complicated to solve. So let's see how we can solve for the possible value of m in this nice exponential challenge. I call it the fourth room exponential challenge. So let's see how we can solve this. We'll say solution. I say solution. Want to solve this? Fourth room exponential challenge. So by the time I say solution, I can write the question with 3 to the power of m minus 2 to the power of m is equals to 65. Like what I said, we can't really apply the direct method solving this, because if you see very well, this base number is 3 and this base number is 2, and if we say we should divide both sides with 2 to the power of m or 3 to the power of m, it's going to make this equation more complicated. So the thing I'm going to do is this. I'm going to multiply both sides with 2 over 2, with the power of 2 over 2. In other words, I'm going to multiply the power with 2 over 2. So in other words, I'm going to say 2 over 2. Recall 2 over 2 is going to give us what? 1. So it still remains the same. So I'm going to say 3m, open bracket, close the bracket, 2 over 2. So nothing still changes. It still remains the same, right? Minus 2m. I'll do the same thing here. 2 over 2 is equals to what? Is equals to 65. Okay, this is what I'm trying to say. Okay, since we've done this. Recall from your indices, if you are having a to m or to n is also equals to a to m n, right? So if I should apply this rule here, I'm going to have m 3 to the power of m times 2 over what? Over n, close the bracket, minus 2 times 2 to the power of m times 2 over 2, close the bracket, is equals to what? Is equals to 65. Okay, recall from your indices rule again. If you're having something like this, if you're having a to the power of 2 over 2, we can write this to be what? A to the power of 2 or to the power of 1 over 2, right? Okay, if we should apply this rule here, we can simply write this to be 3 to the power of 2m, open bracket, close bracket, to the power of 1 all over 2, minus 2 to the power of 2m, close bracket, 1 all over 2 is equals to 65. I'm trying to do out something. Okay, since I've gotten all this, instead of me writing this 2m, I can put this one in, then bring this one out. Put this one in, then bring this one out. So in other words, I'm going to put 1 over 2 inside and bring 2 out. So I'm going to have 3m over 2 to the power of m over 2 or to 2. This one is 2. We're having 2 here. Minus 2m m over 2, open bracket, close bracket, to the power of what? Of 2 is equals to 65. This thing is getting more interesting. Recall I said I'm taking out this one, then putting in this. So since I'm taking out this, I'm going to put multiply this. Recall from your indices, which says if you're having a to the power of 2 or to the power of 1 over 2 is also equals to a to the power of 1 over 2 or to the power of 2. So these two years, that's what I actually applied here. So yeah. So I've gotten this. I can say let 3 to the power of m over 2 equal p, and 2 to the power of m over 2 equals q. So I'm going to write p, we're having square, p square minus we're having q square is equals to 65. Okay, since we've gotten this, we can write again to be p square minus q square is equals to 65. Okay, recall if you're having a square minus b square is also equals to open bracket a plus b, open bracket a minus b. So if we should apply this through here, we are going to have p plus q, p minus q is equals to 65. Okay, we can break 65. Another word, we can write 65. Recall your 65 is equals to 13 times 5. 65 is equals to 13 times 5. So in other words, whenever we say 65, we are putting 13 times 5. So we can say p plus q, bracket p minus q. We're having q here. So q is equals to 13 times 5. 13 times 5. Recall your p plus q is greater than p minus q. In other words, p plus q is going to take 13, p minus q is going to take 5, so that we can solve this simultaneously. So let's move on to solve. Okay, recall I said p plus q is greater than p minus q. Then I said p plus q is going to take 13 and p minus q is going to take 5. So in other words, I can write this to be p plus q is equals to 13. Then I can call this one equation 1. Then p minus q is equals to 5. So since I've gotten this, I can solve for the value of p and q simultaneously. Call this one equation 2. So if I'm solving simultaneously, I'm going to have this plus this is going to give me 2p is equals to, so this and this will cancel off. 13 plus 5 is going to give me 18. So therefore my p is equals to 9. Sorry, is equals to 9. Is equals to 9. We can write this. My p is equals to 9. So I've gotten for the value of p. Recall for my equation 1, p plus q is equals to 13. Right? Okay. Since I've gotten p, I can substitute in place of p. I can substitute 9. So I'm having 9 plus q is equals to 13. Making q the subject formula, q is now equals to 13 minus 9. So therefore my q is equals to what? Is equals to 4. So therefore my p is equals to 9, my q is equals to 4. Recall we said we took our p to be equals to 3 to the power of m over 2. Right? Then we say our q is equals to 2 to the power of m over 2. Recall our p is 9, so we can say 9 is equals to 3 to the power of m over 2. Right? So we can write 9 to be 3 to the power of 2 is equals to 3 to the power of m over 2. So this and this will go. We are now having 2 is equals to what? Is equals to m over 2. So if we want to look for m, our m is equals to 2 times 2. Therefore, our m is equals to 4. If we do the same thing for this one, where your key is 4, so we can say 4 is equals to 2 to the power of m over 2. And we can write 4 to be 2 to the power of 2 is equals to 2 to the power of m over 2. Right? So this and this will go. Recall we're having 2 here. We're now having 2 is equals to m over 2. So therefore our m is equals to 2 times 2. Our m is equals to 4. Since we've gotten the value of m, this is the value for m. So your m is equals to 4. I can write it here. Your m is equals to 4. So this is the value for m. So let's see whether the value of m is correct by substituting this into the previous question. Recall the question still remains the same. 3 to the power of m minus 2 to the power of m is equals to 65. Since we've gotten the value of m, then let's substitute. We can say 3 to the power of 4 minus 2 to the power of 4 is equals to 65. We are having 2 to the power of 4. 2 to the power of 4 is same. 3 to the power of 4 is same as 3 times 3 times 3 times 3. And 2 to the power of 4 is same as 2 times 2 times 2 times 2. And 3 times 3 is going to give us 9. 9 times 3 is going to give us 27. And 27 times 3 is going to give us 81. So in the place of 3 to the power of 4, we are writing 81 minus 2 times 2 is going to give us 4. 4 times 2 is going to give us 8. And 8 times 2 is going to give us 16. Okay? So in the place of 2 to the power of 4, we are writing 16 is equals to 65. So 8 minus 81 minus 16. We can do that here. 81 minus 16. 1 minus 16 cannot. We borrow 1 from it. We are having 11. 11 minus 16, we are having 5. So we are having 7, remaining 7 here. 7 minus 1 is going to give us what? 6. So we are having 65. So 65 is equals to 65. So by the time we substitute m equals to 4, it gives us 65 is equals to 65. In other words, the value of m is correct. So if you find this video useful and interesting, please don't forget to hit on the subscription button and turn on the notification bell. And don't forget to hit up the thumbs up button. Bye for now. I love you, and people of Bright Brain City Grass loves you. And remember, Jesus also loves you. Bye for now once again, and see you in my subsequent video. Bye bye.